Welcome to Skill 3, Regrouping and Breaking Apart Fractions. Before we get started, you should have your notes page, something to write with, and your crayons or colored pencils. You can either take notes as I show the notes on the screen, or if you like, you're welcome to watch the video, pause when it's convenient, and then catch up on the notes. Try both strategies to figure out which one works best for you. Remember, anything that I put on my notes, you need to put on your notes. So to start with Skill 3, we are regrouping and breaking apart fractions. Basically, we're trying to figure out when we have enough fractional pieces to make a whole number, or how can we take a whole number and cut it up into fractional pieces. To do that, let's start with an important vocabulary term. I'm going to box this right here, mixed number. A mixed number is a number made up of a whole number and a fractional number. Let's look at some examples so we are all clear on what a mixed number is. Our first example here is 2 1/3. The 2 is our whole number. And the 1/3 is our fraction. 2 1/3 is made up of a whole number and a fraction, so it's a mixed number. Our next example is 13 7/8. 13 is our whole number, and 7/8 is our fraction. Again, this is a mixed number because it has a whole number and a fraction. Continuing on, we have this one. It looks kind of scary because it's bigger, but it's still a mixed number. It has 516, which is a whole number, and it has 27 hundredths, which is a fraction. All three of these examples are mixed numbers because they're made up of a whole number and a fraction. Now let's look at some non-examples. Non-examples mean that they're not mixed numbers. I'm going to put an X up here in red to remind myself these are not mixed numbers. My first example here is 7. 7 is a whole number, but it doesn't have a fraction. It's just a whole number, so it's not a mixed number. My next example here is 12 25 hundredths. Now, remembering what we remember about decimal work, I know that this 12 here is a whole number, and I have 25 hundredths. Now, I could have written 25 hundredths like this. If I wrote it like that, it would be a fraction, but that's not how they wrote it. They wrote it like a decimal, so I'm going to write the word decimal. Let me erase this. That's not a very good. There we go. So because of the way they wrote it, it's not a mixed number. It's a decimal number. I've got a whole number and a decimal, not a mixed number fraction. This last number here, 3/5, is a fraction, but it doesn't have a whole number, so it's not a mixed number. It's just a fraction. So these are examples of what makes a mixed number. They have a whole number, and they have a fraction. And what does not make a mixed number? If I don't have a whole number and a fraction, it's not a mixed number. Now that we know what a mixed number is, we want to know how we can turn a fraction into a mixed number. So that's what we're going to work on here. It says to turn an improper fraction into a mixed number. Now, we haven't yet talked about what an improper fraction is, but don't stress, that's on the next page. But I want to turn them into a mixed number. Let's take a look at the fraction they gave us. They gave us this fraction here, 5/3. Now, when you look at this fraction, I hope that you notice the denominator is smaller and the numerator is bigger. When I notice I've got a bigger number on top, that's a clue to me it could be written as a mixed number. I've got enough pieces to make a whole number. So for this one, we have 5/3. We have 5 pieces, and those pieces are the size 1/3. And so they drew them out here using pattern blocks. If you've been working with us to use pattern blocks, we know that this blue rhombus is equivalent to 1/3 of the whole yellow. So I'm going to label each of these as 1/3. These are my 1/3 pieces. And in fact, I'm even going to color them in blue. I'm going to ask you to grab your blue crayon or colored pencil. Let's color them in like pattern blocks. Hopefully you can color a little bit nicer than my computer can. See if I can make that smaller. There we go. So these are my 5 1/3 pieces. The big idea is I'm trying to put them together in a way that they look like a whole number. So you can see here, we've pushed 3 of those 1/3 pieces together, and now it has the same shape as a whole number. So this is, oops, erase that. This is a 1/3 piece, and this is a 1/3 piece, and this is a 1/3 piece. When I push them all together, I get the same shape as one whole. So I'm going to write these like 3/3. And then over here I still have another third and another third. All together, when I count them, I have 1, 2, 3, 4, 5. I still have 5/3, but I've grouped them in a way that I can see my whole number and my leftover pieces. So I've got 3/3 to make up the whole number, plus 2 more thirds left over. 3/3 plus 2/3. And I'm going to do something special here to this 3/3. I'm going to box it to remind myself when I push those 3/3 together, they make one whole. In this next section, you can see here's where my 3/3 were, but they're not cut into thirds anymore. In fact, if I were to color this in, it would look like this. They've taken those 3 1/3 pieces and swapped it out for one whole. These 3/3 are now one whole. My 2/3, hopefully you noticed, didn't change at all. They're still there. I didn't have enough to make another whole number. So they're still 2/3. I have one whole and 2 more thirds. And then I can write it as a mixed number, 1 and 2/3. 5/3 is equivalent to 1 and 2/3. While working through this, I'm constantly thinking, how many whole numbers can I make? That's the goal of forming a mixed number. You're just looking at your big fraction with a numerator bigger than the denominator and asking yourself, how many whole numbers can I make? Now, sometimes that works out great, and I can use my pattern block pieces and push them together, or I can draw them. But sometimes when working with a denominator, that's a little trickier. So let's look at a mathematical way to solve it without drawing or using pattern blocks. For this one, they're asking us to solve it. Solve it means I'm writing it like math. Oops. So for this one, we are working with the fraction 12/15. And again, when I look at that, I can see that my numerator is bigger than my denominator, which is smaller. If I've got a numerator bigger than my denominator, it tells me I have enough pieces to make some whole numbers. To do that, we took the number 12 and we started breaking it up into groups of 5/5. So here we have 5/5, and I can box that. That tells me that that is worth one whole number. And then they made another group of 5/5. That's another whole number. If I think about those, 5 plus 5 equals 10. I had 12/5 to start. I now use 10/5 to make these. I don't have enough to make another group of 5/5. If I've used up 10, I have 2 left over, and that's where we get this one. It isn't enough to make another group of 5/5, so I'm not going to box it. So I have one group of 5/5, another group of 5/5, and then 2/5 left over. 1 plus 1 plus 2/5. The next step, they just grouped my whole numbers together to write the number 2. So now I have 2 plus 2/5, and then to write it as a mixed number, I don't need to show the plus sign anymore. I just have 2 and 2/5. Now let's try it out with these practice problems. When you're working on the practice problems, you can choose to work with me, or if you prefer, you can work on your own and then check your work against mine. It's totally up to you. All right, so for the first one, we're working with 7/3. So I know if I'm working with 7/3 that I'm going to make groups of thirds. To make a whole number, I need 3/3. If I started with 7 and I used up 3 of them, I have 4 left. That's enough to make another group of 3/3, so let's make another group of 3/3. If I use up those 3/3, I have 1 left. That's not enough to make another group of 3/3, so that leaves me with just 1/3. 3/3 plus 3/3 plus 1/3. I know that this 3/3 is worth 1, and this 3/3 is worth 1, and then I have 1/3 left over. Now I can combine those. 1 plus 1 is 2, plus 1/3, and then to write it like a mixed number, I just write 2 and 1/3. So 7/3 is equivalent to 2 and 1/3. Moving on to the next one, you can either work with me or you can pause the video, solve it on your own, and check your work. Here I'm working with 17/5. 17/5. And since I'm working with fifths, I know I need to make groups of 5/5 to form whole numbers. If I take one group of 5/5, I'm going to write that up here, 17 minus 5. I have 12 left over, so I can make another group of 5/5. Take away 5. 7 left over, I can make another group of 5/5. Minus 5. I've got 2 left over. That's not enough to make another group of 5/5, so those 2/5 will be like a remainder. I have 5/5 is worth 1, 5/5 is worth 1, 5/5 is worth 1, and 2/5 left over. Combine my numbers. 1 plus 1 plus 1 is 3, plus 2/5, and I can rewrite that like a mixed number, 3 and 2/5. That can go up here. Oops, I didn't give myself a lot of room. Let's try the last one. 16/4. I'm going to write my 16/4. Since I'm working with fourths, I know I need to take away groups of 4/4. 16 minus 4 is 12, so I could keep going. Plus 4/4. Ooh, I've got 8 left. I know 8 will give me 2 groups of 4/4. 4/4 plus 4/4. If I'd use up those 8, I have 0 left. I don't have a fraction in this one. 4/4 plus 4/4 plus 4/4 plus 4/4. I wrote that as 1 plus 1 plus 1 plus 1. Add them all up and you just get 4. So this one doesn't make a mixed number. This one makes a whole number. This is the strategy for working with mixed numbers and turning improper fractions into mixed numbers. You can either pause the video to get caught up on your notes or move on to the next page as we talk about improper fractions. The second piece of this skill is to look at this concept of improper fractions. So let's go ahead and box that. Improper fractions. An improper fraction is simply a fraction where the numerator, that's the top number, is bigger than the denominator. So remember, if you have a fraction, your numerator, I'm going to put an N for numerator, is on top, and your denominator is on the bottom. And the big idea that I'm looking for is if the numerator is bigger Anytime I have a fraction where the numerator is bigger, it means that there's a whole number hiding in there. So let's look at some examples of improper fractions. Looking at this first fraction here, we have 11 thirds. Now I know that 11 is greater than 3. My numerator is bigger than my denominator. That means it's an improper fraction. It's got more on top than on the bottom. Basically, that means there's a whole number hiding in there. And if you remember our notes from earlier, I can think, well, if there's 11, I have 3 thirds, and 3 thirds, and 3 thirds, and 2 more thirds hiding in there. 11 thirds is an improper fraction because I should really write it as 3 and 2 thirds. It's an improper fraction because it could be written as a mixed number. But for some reason, they decided to leave it as an improper fraction. And often there's a good reason for it, but right now we're just working to recognize them. I'm going to erase some of this. You can leave it in your notes, or you can choose to erase it, your choice. All right, let's look at the next example. Here I have 71 eighths. And again, 71 is greater than, let me draw that better, is greater than 8. The 71 is bigger than the denominator, so it's an improper fraction. Here's another example. Even though they're both really big numbers, I know that 113 is greater than 100. The numerator is bigger than the denominator. Now here are some non-examples. You'll remember from the last page of notes that non-examples means it's not an improper fraction. This first one here, 9 and 13/100ths, this is a decimal. It's not even really a fraction, so it's not an improper fraction. My next number here, 4, this is just a whole number. An improper fraction isn't about being a whole number. Let's look at this one. It is a fraction, but in this one, 5 is less than 6. My numerator is not bigger than my denominator. It's actually smaller. Oops, let me go back to the page I was on. There we go. It's actually smaller than my denominator. So I can say 5 is less than 6. This is just a regular old fraction. It's not an improper fraction, it's just a fraction. So now that we understand this idea of what an improper fraction is, you might be asking yourself, well, what do I need to do with it? So we're going to work on this skill here. We're going to turn a mixed number into an improper fraction. Some different math skills are going to ask you to start with a mixed number and then cut it up into an improper fraction. So here's the example we're working with. They gave us the mixed number 2 and 5/6. Now this 2 is our whole number. And then the 5/6 is our fraction. And so what we've done here is that we built 2 and 5/6 out of pattern blocks. Let's go ahead and color them in so they really look like pattern blocks. We've got our 2 whole yellows. And then to show 5/6, we have 5 green triangles. Let me see if I can make that work better. There we go. So we've got our 5 green triangles. And I know each of these is worth 1. That's my 2. In fact, I can even go like this to show it, 2. And then here I have 1/6, and 1/6, and 1/6, and 1/6, and 1/6. This altogether is my 5/6. So 2 and 5/6. To turn this mixed number into an improper fraction, I need to cut my whole number up so that I only have 6ths. I don't want to see 2 and 5/6. I want to cut it all up into 6ths. So I could draw that. If I go like this, It's like I cut it up into all those triangles. And if you count the pieces, 1, 2, 3, 4, 5, 6, I can see that it would take 6 sixths or 6 triangles if I cut up that one hole. Same thing with this one. I can cut it up and I can count the pieces. 1, 2, 3, 4, 5, 6, and that would be 6 more sixths. So I have 6 sixths from this first whole number, plus 6 more sixths from the second whole number. And then if you remember, there were already 5 sixths from before, so I can add all those up. 6 sixths plus 6 sixths, that's 12, plus 5 more. 12 plus 5 is 17. 17 sixths. Now let's count all of these triangles here. We should have 17 of them because we cut each of these whole numbers up into 6, and then we had the 5 that we started with. Let's touch and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And I can even color them green. The big idea is I traded in or cut up my whole numbers so that it's all in the same size pieces. I don't want to have some whole numbers and some fractions. I want it all expressed in terms of those fractional pieces. And then again, we have our thinking bubble down here, and it's asking us to think. When I'm trying to go from a mixed number to an improper fraction, I'm just thinking, how can I cut up my whole numbers into fractions with the same denominator? I just needed to cut them up into sixths. Now, some numbers you can just draw it out and do your math that way. But drawing can be tricky, and sometimes it's not easy to draw. Sometimes you get a number that's not so, we call it conducive to drawing. It doesn't draw as well. So let me show you a way to solve it. There's actually 2 ways to turn a mixed number into an improper fraction. We can use the addition method. I'm going to ask you to box that with me. Solve it, addition. To do that, I'm going to start with my whole number and my fraction. And if I look at my whole number, it's a 3. So I should have 3 groups that are worth 1. And each of them needs to get cut up into fourths because that's what I'm working with for my fraction. So I have one group of 4 fourths, and another group of 4 fourths, and another group of 4 fourths. That's my 3. That all ended up here. And then my 1/4, I just added in. 4 plus 4 is 8, plus 4 more is 12, plus 1 more is 13 fourths. So I can use the addition strategy. I can write each whole number as a fraction using the denominator they gave me, and then add it all up. A faster solution is the multiplication solution. This can be really helpful when you have a mixed number and the whole number is a big number. So let's look at this example of 2 2/5. To do this strategy, I could write out 2 in terms of fifths. I could say 5/5 plus 5 more fifths, and that would be 10/5. Or I could look at it this way. I could say, what is 5 times 2? 5 times 2 is 10. Here's my 2, and I've got 5 plus 5 is 10. Or I could just multiply it. 5 times 2 is 10. And then I'm going to add in my 2 extra pieces. 10, oops. Sorry about that. There we go. 10 plus 2 is 12. So my new numerator is 12. My denominator, you'll notice up here, stayed fourths the whole time. When I'm converting a mixed number into an improper fraction, my denominator stays the same. So I get 12/5. Let's try the multiplication strategy again over here. I have 1 7/8. First I multiply, First I multiply my denominator. Let me get it to work. There we go. First I multiply my denominator times my whole number. 8 times 1, that's 8. And then I add in my numerator. 8 plus 7 is 15. My denominator doesn't change. That's the size of my pieces. So 1 7/8 is the same as 15/8. Now if you chose to write it out, I could write my 1 as 8/8 and then add my 7/8. And again, you would get 8 plus 7 is 15/8. Same answer. So as you're working through these problems, if you're feeling not too confident with the strategy yet, I would stick with the addition. I would write each whole number out. And if that makes a lot of sense to you and the multiplication strategy makes sense to you, then feel free to use that. On the try it problems, I'm going to show it both ways. So whatever way you're trying, you can check your work against mine. Now remember, for try-its, you can either pause the video here, work them out on your own, and then check your work against mine, or you can work with me as we add these to our notes. All right, we have 1 2/3. I'm going to start with the addition strategy. I'm going to turn my 1 into a fraction. I'm going to cut it up into thirds. So I've got 3/3. There's my 1. And then I've got 2 more thirds. Add it up. 3 plus 2 is 5. And I'm working with thirds. Or I can use the multiplication strategy. 1 2/3. 3 times 1 is 3. 3 plus 2 equals 5/3. Either way, 1 2/3 is equal to 5/3. Let's try the next one. I have 6 1/2, so I need to cut my whole number up into halves. I could write 2 halves 6 times. 1, 2, 3, 4, 5, 6, and then 1 more half. Sorry, it's sneaking into the next problem. And then I could add up all my halves. 2, 4, 6, 8, 10, 12, plus 1 more is 13 halves. Or I could use the multiplication strategy. 6 1/2. 2 times 6 is 12. 12 plus 1 is 13. My denominator stays the same. And either way, I get 13 halves. Or 13/2. I'll go back and circle those. All right, for the last one, we can do the same thing. Let's start with the addition strategy. I've got 4 is my whole number, and I need to cut it up into eighths. So I've got 8/8, and I'm going to do it 4 times. 1, 2, 3, 4. And then I have 3 more eighths to add in. Let's do the adding. 8 plus 8 is 16. 16 plus 8 is 24. 24 plus 8 is 32. 32 plus 3 is 35. And my denominator is eighths. 35/8. Let's check it with the multiplication strategy. 4 3/8. 8 times 4 is 32. 32 plus 3 more, you guessed it, 35. My denominator doesn't change, it's eighths. So 4 3/8 is equivalent to 35/8. These are the notes pages for skill number 3, where you are working with mixed numbers and improper fractions. Please make sure to check your notes. If you were just watching the video and wanted to go back and make sure your notes are caught up, you're always welcome to scroll through the video, but you are responsible for having completed notes when you come to group. We're going to do some highlighting together to go over important concepts, and then we'll do some practice problems.